Alright, let's look at the homework 3.4, problem number 6. Alright, so we have a rectangle inscribed in a semicircle with radius r, and we want to make this as large as possible. Alright, so let's say the equation of the circle is y is equal to square root of r squared minus x squared, right? So that's the equation of the semicircle. Right, so if you want to express the area, which is here, area of the rectangle here, right? So what we need to do is, since it's a rectangle, so we just have to do a base times height, right? So let's write that. So here, area A with respect to x here, right? So this is x. So you have two of these. So the base is going to be 2x, right? So a of x, base is 2x times height. Height is simply square root of r squared minus x squared. So we just multiply by square root of r squared minus x squared, right? And what we want to do is we want to maximize this function on, right? So the x can move from 0 to r. So let's go from 0 to r on the closed interval, right? So let's find the critical number. First thing I would do is I'm going to just rewrite a little bit before we take the derivative. So you have a 2x, then it's a quantity, r squared minus x squared raised to the 1/2 power, right? So let's take the derivative. A prime of x is equal to, right? I'm going to leave 2 alone here, right? Derivative of x is 1 times the second, so you have r squared minus x squared raised to the 1/2 power, plus x times derivative of the second guy would be put 1/2 in front, leave the inside function as it is, and subtract 1 from the power, so it's a negative 1/2 power. Then you multiply by derivative of inside. Derivative of r squared is 0 because r is just a radius, it's a constant. So it's going to be negative 2x. Right, so let's simplify this. So we have a 2 is already here. All right, then we have, right, I'm going to just rewrite it as a square root of r squared minus x squared, right? Then here we have 2 on the bottom, 2 on top, cancel out. But we still have a negative sign here, so it's going to be minus. Then we have, let's see, there's an x here, there's another x, so that will be x squared on top. Right, so we have a negative power, so I'm going to put the r squared minus x squared on the bottom. So you have r squared minus x squared on the bottom. Right, then we have a 1/2 power, so that would be square root. Right, so we have that. Then we're going to just take the maybe a common denominator and to simplify a little bit further. Right, so 2 is out here. Right, then I'm going to take the common denominator, square root of r squared minus x squared, right? So we have to multiply by square root of r squared minus x squared by itself. So you have r squared minus x squared, right? Then minus, you have x squared on top here, right? So this is going to be 2 times, right, r squared minus 2x squared over square root of r squared minus x squared. Right, so let's set this guy equal to 0 to look for critical number. So you can see that the critical number would be let's see, we get r squared minus 2x squared equals 0, right? Then I'm going to, let's see, subtract r squared. So we get the negative 2x squared is equal to negative r squared. And then I'm going to divide through by negative 2. So we have x squared is equal to r squared over 2, right? And then we can just take the square root of both sides. So x is equal to plus or minus square root of, so let's say square root of r squared would be r. Then you have a square root of 2, right? Since we're talking about the x between 0 and r, so we just take the positive one. So it's a positive over square root of 2, right? So if you do, if you check, the area at the endpoints, which is 0 and also r, right? And then area at the critical number, which is r over square root of 2, right? But when x is 0, area is going to be obviously 0. And x is equal to r, you can see that, let's see, r squared minus r squared is 0, so it's going to be 0 as well, right? But if you put the r over square root of 2, you'll see that this is going to be bigger than 0, so let's plug it in. So you have a 2 times r over square root of 2, right? Then you have a square root of, you have a r squared minus, and r over square root of 2 squared would be r squared over 2. Right, so this is going to be 2 times r over square root of 2. Right, so this is going to be a square root of r squared over 2, so this is another r over square root of 2. Alright, so 2 and square root of 2 times square root of 2 cancel out, so you actually get r squared. Alright, so that's the area. Alright, so let's answer the question. So x is going to be r over square root of 2. Right, and y is going to be, actually we have to find the y, right? But the y is just simply y is equal to square root of, right, r squared minus r over square root of 2 squared, which is going to be square root of r squared over square root of 2 over 2. So it's going to be just r over square root of 2. It's actually the same as x. All right, so you have r over square root of 2. All right, so let's check the answer. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.